Hey everybody! So we've made it to lesson 6 in Unit 8. We're in the home stretch, getting close to vacation time. So here we're still working with that form, something outside parentheses, P, times parenthesis Q plus or minus X plus or minus Q close parenthesis equals R that I just highlighted here. It's easier to look at than it is to say. And then we're going to introduce another way you can solve it that I've actually already kind of shown you. So a little bit of a spoiler back there. Sorry. um, and then I wanted to talk about in the keywords. So this is you know how sometimes they'll have more keywords in the middle of the lesson? They have all this stuff like complex numbers, um, and powers that really are not necessary. They're just mentioned in the lesson, so they feel like they have to define them. So let me show you where they're mentioned. Okay. On this page, page 12, it says algebra is a more advanced level of mathematics. Algebra combines the use of unknown quantities or variables with numbers and operations. Algebra uses integers, we know those, and rational numbers, we know those. Complex numbers, so those are just, you know how we talked about something's either rational or irrational? If it's neither of those, it's imaginary. Okay. So those are the complex numbers, those are the imaginary numbers. And powers. Okay, but we won't use powers. You're going to use them next year. Okay, in 8th grade math. But one really important idea in this lesson is an algebraic method versus an arithmetic method. So basically, algebra, if we're solving the problem using algebra, we're setting up an equation and we're solving it. Okay, if we're not setting up an equation, we're just doing things with the numbers in the problem, we're adding them together, we're dividing. That's an arithmetic solution. Okay, and their point here is that we can use either to get the answer for these equations that you're dealing with. Okay, for these word problems that you're dealing with. And so they say here, in this, why solve it algebraically if I can just do the math? And we're using it for higher math so that we're better at it when we get there. For 8th grade and high school math. But also it's just a little more systematic. I think you're a little bit more clear on why you're doing what you're doing when you make an equation. So let's look at a problem together. This is one of your practice problems, item 4. There are 2 types of tickets to attend an awards dinner, silver and gold. The gold tickets are $8 more than the silver tickets. If Patrick bought 10 tickets at each level and spent a total of $140, find the price of each ticket. Okay, so what I'm thinking here is, let's see, we know gold is 8 more than silver. We know the total. Okay, we know that he bought 10 of each kind. I'm thinking let's let S equal the number of silver, or the price. Ooh, did you see that? So find the price. That's where, okay, your variable is your unknown. I don't know the price. Okay, so the price of a silver ticket. Okay, and that means that S plus 8 equals the price of a gold ticket. All right, so if I bought 10 of each of these, I bought 10 of the silver, okay, and I bought 10 of the gold. So I could put 10 and then parenthesis silver plus gold, right? But gold is S plus 8. So I get S plus 8. All of that cost a total of $140. Okay. So what I did here, I added up the price of the silver tickets. That was S. Let me highlight this for you. So this is the price of the silver ticket. And then I'll highlight the gold ticket in a whole other color. Let's look at this in green. Okay, and then so the gold ticket is here. It's the S+8. That is this. So I have 10 of, 10 times the price of the silver and the gold tickets. Okay. And then, if we rainbow this in, as I've been saying, if we distribute here, this will make sense too. We have 10 times the silver ticket, right? 10 of those silver tickets. And then we have 10 times the gold, but the gold cost the silver plus 8. So that's plus 10s plus 80. All of that equals 140. Okay, that's if I rainbow it in. Oh, should I use the Pearson method? Let me do that too now. There's actually a lot of ways you could skin this cat. So the other thing is, okay, here's the other thing. You could combine like terms before you distribute. 10 times 2s plus 8. Everybody's at home like, when's she going to solve this equation? How many ways do we need to do it? Let me just show you one more thing we can do here. Instead of distribute that 10, and then come here, I'm moving you. Need a little more room, guy. Okay, so instead of distributing the 10, remember that we can divide on both sides by 10. These are going to cancel out because 10 over 10 is 1. And then if we divide these both by 10, it's just going to take away a 0 in the 140 and leave us with 14. So see, that's really nice because look how cute my equation is now. It's just a nice little two-step equation. No big deal. I'll subtract 8 on both sides. 14 minus 8 is 6. And then I'm going to need to divide on both sides by 2. Let's do that in blue. Divide by 2. 2s put into 2 groups. There will be 1 s in each group. And then 6 divided by 2 is 3. So, what does that mean? Silver is $3. Gold is going to be 3 plus 8. Because remember, the gold are $8 more than the silver. So gold tickets will be $11. Okay. So yeah, that's what I was supposed to get. Okay. How can we solve that one without algebra? Well, maybe I would have said like, oh, well, that 140 was for 10 tickets, so I'll divide by 10. And, or 10 bundles of tickets, right? So that means it's $14. And so I have to think of like, one of them's $8 more than the other, so maybe I'll subtract 8 and then divide by 2 to get the cheaper ticket. Okay, and all of this. And so, doing this is fine, but you might lose track of a step. So this is the arithmetic solution. Arithmetic solution. Sorry, that got a little messy there. Arithmetic solutions get a little messy sometimes. Okay, let's look at another problem and see if we can keep getting our heads around this idea. This says this is a quick check problem. 3 adult and 3 child movie tickets were purchased for $75. The cost of each child ticket is $3 less than the cost of an adult ticket. The first step to solving this problem algebraically is to write the equation, where x represents the cost of an adult ticket. Identify the next step, which would simplify the equation before solving for the variable. Okay, and so I did this one in the other problem, but I just wanted to kind of do this one for you because they've got some answers here that could be correct. There's nothing wrong with distributing values over the variables. You could rainbow in this 3 and you'd be absolutely right, and that'll be the first thing you do. Okay, but the gods of Pearson have declared that we are going to combine the like terms. Okay. Hey, check out this here. Is there anything wrong with dividing 75 by 3? No, remember that's the Pearson method. I don't know why they don't like it here. Remember, if you divided by 3, you would do it on both sides. Maybe because they didn't say do it on both sides. Maybe that's why. Okay. Add 3 to 75. This one is just not mathematically correct because the 3 outside parentheses is 3 times whatever's in parentheses. So we can't undo multiplication with addition. All right, but this is the answer that they have declared the first step to solving this equation, even though it's not the only thing you could do. All right, there was one more problem here that I pulled that I want to talk about, and it is important. So let me just get myself a little space over here to the left and we'll do it. Erg. This problem doesn't want to come with me. Come on, little problem. Here we go. All right. Okay, when solving the equation -1/2 parenthesis x plus 10 equals -3, identify the operation that should be done first. Like I say, Pearson's getting a little judgy here. You could decide that you wanted to distribute as your first step. But should you? It's a little judgy. Okay. Here, if you look, we've got -1 times some stuff in parentheses. Okay. And they're saying, let's get rid of that -1. Okay. And they want us to multiply by 2. Okay. Here's why. If you multiply, or -2, if you multiply by the reciprocal, which is a great thing to do to get rid of a fraction, okay, the reciprocal of 1/2 is 2 over 1, and then we're going to multiply by -2, because if we don't, we'll have a negative parenthesis, and there's nothing worse than a negative parenthesis, right? So a negative times a negative is a positive. So these basically, if you multiply straight across, this becomes 2 over 2, which is just 1. And then we say, well, I don't need to write times 1, so those fractions are gone. You can think about cross-canceling if you want, but either way, we're multiplying this stuff in parentheses times 1, and we don't usually write times 1. So now we have this -3 times -2. Okay, I do want to point out here, subtract 10. This is a very bad thing to do. Okay, and the reason is that's not actually a 10. Think about it. I know it looks like a 10, but with the 1/2 outside the parentheses, okay, that 10 is really a -5. Of course, okay, because it's the opposite of 1/2 of 10. Okay, when you rainbow things in, you got to multiply them. 1/2 of 10 is 5. Negative times a positive is a negative. So I know that looks like a 10, but it's actually a -5, so you cannot get rid of it by subtracting 10. Okay, you really can't get rid of it by adding 10. that would just turn it into a 20. Okay. Divide by -2. There's nothing algebraically wrong with doing that, but it doesn't help you. Okay. Anyway, good luck with these. Do the best you can. They're word problems. Don't stress over them to the point where you're tearing your hair out. Okay, keep that hair on your head.